this problem where we unstacked it, and then we're using the box 3r minus 2, 3r minus 2 on either side. And then this last box, a negative 2 times a negative 2 is going to be a positive 4. So in this case, I'm going to pull everything out now. So it comes out as a 9r squared. And then these are like terms. Who knows how this comes out as?
Negative 4r.
Very good. So there's 6 of them, 6 more. Altogether there's 12 of those r's, and same sign, sum, and there's more of the negatives. Plus the 4, and that's it. So that is your answer for this right here. That is 9r squared minus 12r plus 4. We're going to wrap up these two because you're only going to have a couple like that. So same thing on the number 28. So again, the best way is the box. So this is going to be x. Okay, excuse me. So 2y, and then on this it is 3x minus 4y. We don't need to be talking, boys. And so on this, the 3x times x.
Right, can you go look at them?
3x times x
3x squared
is 3x squared. This time I'm just going to go to the bottom. So negative 4 times a positive is a negative 4, and then x times y, put them in alphabetical order, is xy. And then going to this upper box, negative 2 times a positive 3. Joelle, take it off. Get it off.
I'm just trying to read.
Okay, get it off your head though. All right, so on this one, negative 2 times 3 is negative 6. X times y is xy. And then right here, negative 2 times negative 4 is a positive 8y squared. And then you're going to pull it out. There's only one x squared, so I'm going to actually put it right here. 3x squared. These are xy, and that's xy. So they're the same sign. So what are you going to do with those? Same sign sum. And there's more of the negatives. So it's a negative 10xy. And then that last one pull out as 8y squared. And that is it. But then I'm hoping on the back, well, I don't see it on there, but you will have one. I'm just going to add this on there. You will have one that is like this. I'll just put it as an example of x minus 4y and x plus 4y. So I would write that down because you will have one like that on the test. So if I'm asking you to multiply that, again, I would do the box. And it's going to be, again, you put these along the top or the side. It doesn't matter. And then put the other one on the opposite top or side. So x negative 4y, x positive 4y. So this one right here is going to be what? X squared. This one right here is a negative 4 xy. This bottom one is a 4xy. And this one here, negative 4 times positive, is a negative 16y squared. Then when I'm pulling this one out, for sure I have the x squared. But what happens when I have a positive 4xy minus 4xy? They cancel out. That's why when you have the exact same numbers, except one's a negative, one's a positive, that middle will drop out. And the only other thing I have is a negative 16y squared. So again, you will have one like that. And then, okay, starting with the rest of them, I'm going to do a couple and then I'm going to leave the rest for you to do. I'm going to start with, we'll start with this number 41. So you always start by, and I would start it on your line paper because you don't know how much space it's going to take. On number 41, can you see anything at all that goes into the numbers?
8,
Bigger.
12,
12 doesn't go into it.
16.
16. 16 goes into both. And does a y go into both?
Yes.
So we can pull out a 16y, and a binomial is left. So who knows how many 16s are in 64? 4 of them. And if I'm pulling out one y, how many y's are left?
Squared.
Y squared. And this is one that I'm pulling everything out, but don't just put nothing. 16y times what will give me negative 16y? A negative 1. And then on this one, you need to look at it again.
6y.
Okay. Is this does 4 have a perfect root?
Yes.
And 1 has a perfect root. It's the difference of perfect squares. Difference of perfect squares can be factored again. And again, if it's a negative, who knows the two signs?
Negative and positive.
A negative and a positive. How am I? And these are going to be the exact same numbers, such that the middle will drop out. So who thinks they know what the 4y squared is going to break up into?
2y.
Very good. 2y times 2y. And how am I going to get a 1?
1 and 1.
1 and 1, such that the inside is negative 2y, the outside is positive 2y. It would cancel out. This is your final answer. So we'll do a couple of those. That's going to be 16y. Alrighty. Then I don't think I want to do this one.
No. You don't.
That 2 can come out. I don't know the number.
Oh, really?
Would it be 52? Oh,
Well, because it ends with a 5, it's not going to be a 52. So I'm going to take 52 and I'm going to factor it into 2 times 26, and that is 2 times 13. It might be 13. That's too hard. It might be 13 that's in it. I'm just curious, but I don't think we're going to, you will not have one that big. But now I'm just curious if 13 will go into it. That is going to be 2, 26. That is going to be 4, 5, 6. Yes, it is 13. And that's going to be 5 times that. So I'm just going to factor out the first part so you can see what's left. So if I factored out a 13, if I factored out a 13, we have to figure out what's left. Oh, 13, it would be 25 is left. How many y's can we take out?
6.
6y. So I can take out y to the 6th. And then what's left is 13 times 25.
25.
And we took out 6. How many are left?
Y squared.
Y squared. Actually, once we have that 13, then the rest is going to be easy. And then 4 times 13 is 52. So minus 4, and we pulled out all of the y's. So now look at this. Again, you will not have one that big in front. Then, can this be is that a perfect root, 25?
Yes.
And this is a perfect number. So this can be factored out one more time. What's the only thing that's going to give you a 25y squared?
5y.
Okay, oh, so sorry about that. Let me shut this thing off. Alrighty, so it is going to be 5y times 5y. What's going to give you a negative? What signs? Very good, positive and negative. What's going to give you a 4?
2.
a 2. And again, if it's exact same thing, except one's a positive, one's a negative, the middle will drop out. So that is it. We're going to do the one above because you might have this possibly, maybe in the problem, maybe as a bonus. So is 4 a perfect root?
Yes.
Is 16 a perfect root?
Yes.
So it is factorable immediately. Who thinks they know how I'm going to get 1/4? What times what?
1/2.
1/2.
Thank you.
1/2 x times 1/2 x. A half times a half is 1/4. Who thinks they know how we're going to get 1/16?
1/8 and 1/8. No, 1/4 and
1/4. 1/4 times 1/4, because 4 times 4 is 16. And for the signs to be a negative, what do these two signs have to be?
positive and negative.
A positive and a negative. That wasn't that bad.
That was easy.
Okay.
Lemon squeezy.
And then let's go up through this column, and then you're only going to have a few left to do. So what can we pull out of this one? Let's first of all look at the numbers. Oh no, this is 36 is perfect,
And 49.
49 is perfect. So, and there's nothing in common because this is just 7 times 7. What's the highest? Oh, there's nothing. So I'm gonna bring, I can't even pull out a letter. Why can't I pull out a letter?
There are 2 different letters.
There are 2 different letters. So the only thing that we can do is start this and see what we get. So if we start this one on our paper, is on 39. Okay. Is how am I going to get a 36 s squared, x to the 6?
6x
6s to the 3rd
S.
times a 6s to the 3rd. Is that right?
Mm-hmm.
Yeah. Because we multiply the numbers, but we sum the exponents. And then the sign has to be positive, negative. Who thinks they know how we're going to get this 49?
7 times 7.
And 7g times what?
5.
5. Very good. And 7g to the 5th. And this one with the negative is not the difference of perfect squares. So that is your final answer. I thought there'd be something more than this. 6s to the 3rd. And this one, I think is going to be easy. This one, we'll see if we can do it right here. Who knows the biggest number that we can pull out? 8. Very good. And what's the biggest C we can pull out?
2.
C.
1C. What's the biggest D we can pull out?
2.
1.
Only a 1. So we can pull out an 8. C, D, and then 8 times what will give us 32?
8 times 4.
8 times 4. And put it way over here, because I do think this can be factored again. Okay. Minus 8 times, is it 5?
Mm-hmm.
Oh, maybe not. 5. We pulled out a C. How many C's are left?
2.
Are there 2 if we pulled one out?
Oh wait, my bad. 1.
1C. And we pulled out a D, so is there any D left on this one?
1. Oh, I mean cancel.
It cancels out, and then, oh, and that E squared stays there because we didn't pull out an E at all. And that's it. Because is this the difference of perfect squares?
No.
It is not factorable again. Let's go straight up.
Armando rolled again.
What can,
Matthew.
okay, excuse me, shh. Matthew said stay. All right, so what can we pull out on this one?
3.
A 3 and what letters?
M.
An M, a single M, and a single N. I think this is only factorable one time. So if we pull out a 3, it's gone. If we pull out an M, how many M's are left on the first one?
M squared.
Is it m squared? We're
Or
pulling
M
out,
first, or just M.
yeah, just m, and we pull out that entire n, so that n is gone. And just double check, 3mn times m would give you 3m squared n. Plus, if we pulled out a 3 times what gives you 12?
4.
No, it would be M squared.
No, we pulled out an m.
Armando.
There was
Oh,
only
that's
2.
true. Oh, that's
Okay.
true.
All right, so we pulled out the complete m, and we pulled out one n, so it's going to be 4
And
n. Very good. And this is not factorable anymore.
thank you.
Then,
Thank you.
you're welcome.
This
Thank
is
you.
38.
38 is a good one. And I might,
Armando, she said she did the
Okay.
first column.
I know, but it's okay, we can do this one. I'm going to start this one a little bit higher. I have a feeling it's going to be factorable. Well, no, it won't be. It won't be. Who thinks they know? To get a negative, what are the signs going to be? Positive, negative. And then how am I going to get a 4v to the fourth? 2v squared and another 2v squared. How am I going to get a 1?
Who's going home? Is that you, Vanessa?
1 and 1.
A
What time are you leaving?
Joel. Yes, we'll do. Thank you. Vanessa.
Why are you leaving?
You got a what?
Wait, is Eric doing it?
Okay. Vanessa, do you know if Max is going to? No. Okay, all right.
Wait.
Okay,
Is Eric going
okay,
anymore?
Joel, we need to continue. So on this one, it was 1, 1. Now, can this one be factored again?
No.
No, because it doesn't have a perfect root. So you're done. So let's finish up with,
Is Thomas?
some of these are easier than the worksheets that you've had. You're going to have a lot from the worksheets that you've got.
Can we just start working
So,
now?
yeah, you guys, do you know how to do this one now?
Yes.
Yes.
So this is, again, it's going to be a difference of these two factors that gives you that. You're going to finish up the 29, all the ones that we didn't do. So all you have is 1, 2, 3, 4, 5, 6, 7. That doesn't mean you're done. That means you also have to finish up that packet from last week. So you may begin.
Let's work together.
Hard. No.